Hi, so welcome to the another class of Internet of Things. So in this class today we will study about the adaptation layer for your IPv6 over low powered personal area networks. Now we have been studying here that the Internet Protocol version 6 is going to fulfill the demands for the growing IoT things. That means it specifies that each and every small object which is low powered or that requires low throughput that should be able to get connected to the internet. So here we have in the provision of IPv6 for that. So that's quite clear here that we have been here dominated by the internet around us. So previously we have been using here the IPv version 4. So this is basically 32-bit address. But this addressing scheme is exhausted, which has been here delayed or addressed here by techniques like network address translation. But now, since in your IoT, each and every small object is supposed to get connected to the internet, so that means we need billions of the devices. Now, if by 2025 these devices is going to increase by a number of billions, so you need that number of addresses here. So this address space is not sufficient here to meet these requirements. So we're using this IPv6 here for your IoT. So which is basically your 2 raised to power 128-bit address. So which potentially can offer this much billion addresses. So we can say that this addressing scheme is sufficient here to fulfill the requirements of your Internet of Things. That means to fulfill the requirements of wireless embedded internet. Every small object is connected to the internet. And here we can say that IPv6 is connecting more things to the cloud. Now, the protocols like your IPv4 or IPv6, these are heavier protocols. Now, we are using low throughput and low capable devices as compared to the heavy devices in the internet. So that means we need some lighter version of these protocols. So in parallel, this your IPv6 over low power personal area network has been developed, which could be used here to connect the small devices to the internet. That is your using your IPv6 to the internet domain here. So when we started here about this LoWPAN, IPv6 over LoWPAN, we saw in the protocol stack that for physical layer we had the IEEE 802.145.4 specifications. That means the physical layer here, which is your Zigbee devices, and then it's MAC layer. So after that, we have the IP or the network layer. Now implementing IPv6 here for these small Zigbee devices have some issues because the IPv6 is not a natural fit devices. Like your when you have to transmit from this internet to these devices, there should be an adaptation. That means the data packets which will be forwarded here from this layer to this layer, they should be easily transferred. So that's how we have here an adaptation layer which provides the connectivity, or we can say that the interface of the radio link between the Zigbee devices and the network layer here. So always when the data is being transmitted over these two layers, this kind of adaptation is required. Now, why this adaptation is required? What are the issues here which are faced while we are using IPv6 for these ZigBee devices? So the IPv6 datagram, that means the packet format here, is not a natural fit to the ZigBee platform here. That means this datagram, the header of your IPv6 is way too large. That is not possible for this ZigBee network to accommodate. Now, if your IPv6 has a maximum transmit unit size to 128 bytes here, but for your ZigBee device, suppose maximum it is up to 576 bytes here. So naturally, this will not be supported here by the ZigBee device. That means it has to be compressed. In IPv6, we have here like 40 bytes for your address and 20 for your TCP and 8 for your UDP here. So we know that TCP is not mainly supported here, so we will be using the protocols based here on the user datagram protocol, but for that we have to compress the header here. So header compression is the first application of your adaptation layer. Your IPv6 low power personal area network adaptation layer. It has this functionality that it has to compress the header so that it can be transferred over the ZigBee links here. So it has header compression. So header compression is possible here because it sees here that most of the fields here are commonly used. So that means some of them can be reduced here and the header can be compressed. Now, if you have a look at the IPv6 frame format, that how it works. You have different fields here in the IPv6 header, starting from the very first field, which is your version, which basically specifies here that which kind of addressing protocol you are using here, IPv4 or your IPv6. Then you have the traffic class here. Next is your flow label, then the payload, the data which is being carried here, then hop limit, then you have next header, then the destination address, and the source address. Now, this datagram cannot be as in this format transmitted over your ZigBee networks. That means to your ZigBee devices here, it has to be compressed here. Now, this compression here is like divided into three scenarios. So, first, it is in first case, it is here compressed for over 2 bytes. So this compression is mainly done here for allowing the communication between two devices inside the same low powered personal area network. for two devices. This is the compression ratio here, and this is the least of the compression ratio which is achieved here. So this basically consists here of the dispatch field and the compression header here. Now the next case, which is most applicable, the next two cases are the most common cases because we have to transfer the data from Zigbee network to the IPv6, or we have to gather the data from your IPv6 network, or we can say that from the network to the Zigbee devices here, the user devices here. So the second case which we have here is the communication which will act between the Zigbee devices and IPv6 network. We can say here that from this network and between the complete internet. It is compressed to 12 bytes. It has the same fields: dispatch, your compressed header, destination address, your hop limit, and your SA, your source address. Now, after that, last one is compressed to a greater extent. That means that provides the highest degree of compression, that is up to 50%, in which you have 20 bytes compressed here. So this is the most important function of this adaptation layer because it the main aim here is to optimize the connectivity between the two different interfaces here. That is, one is your low power devices and other is your a big web infrastructure. So this adaptation layer here provides the transfer of this data from these physical layer and these MAC layer over to the network layer, which is your IPv6 based here. Now, next we have is segmentation and reassembly. We fragment our data packets into small units and then transfer over the various links here. So the media here is the air interface, so that there could be link failure. So that's why we also require an adaptation layer here for your segmentation and reassembly here, because the packet size, or we can say that the maximum transfer unit size for both of these interfaces is different from Zigbee to your IPv6, which has increased to your 1280 bytes. So if you have frames here, they will be converted here into smaller fragments. Now, this frame here will have its own header. Now, as I'm dividing the frame into smaller fragments, so when I need to assemble this frame at my destination, I again need to convert this frame into one individual frame. So that means I have to assign an identity to these smaller fragments also. So that is basically your fragment header. So that means it has to carry additional headers here so that at the destination they could be reassembled here for your reassembly at the destination only. So basically in your ZigBee you have the mesh network. So this assembly of data packets is done only at the destination point. So basically this adaptation layer then here provides the stacked headers. We have stacked headers here. So first of all, you will have your ZigBee network. You can say this IEEE 802.154 header. Then you will have IPv6 compressed header, and then you will have the payload. Now, if I need to fragment my frame, so that means the fragments will also carry their address. So I will have this header, then I will have my fragment header. Then IPv6 compressed header and the IPv6 payload. Last one, which specifies in this field you will have this. Now, before the fragment header, you will have your mesh addressing header, which will be used here inside the IPv6 low powered personal area network. Then these fields will continue here. That means then you will have the fragment header, IPv6 compressed header, and the payload. So in your stacked header, you start here from this a simple payload which simply have your IPv6 compressed header and the payload. Now when you're fragmenting here the data, you add here another header field, that is your fragment header. Now when you're entering here in the low powered personal area network, you have here the mesh addressing header also. So these are the adaptability functions which are provided by the adaptation layer of this network. This is a low powered personal area network over IPv6 here. The next important thing here is the routing. Now we have seen the architecture here also, that we have here this network having various smaller devices here. Now this is connected to the big picture of your IPv6 with the help of an edge router. Here. So if we talk here about the routing for this network, either we have it The first one is your route over, and the second one is mesh over. Now, this route over here is a three-layered routing scenario. That means it is carried over here, the network layer or your IP layer, only at this layer. Now, this mesh over routing is your at DLL layer, that is your data link layer. It means two layers only. So this is for your local network, and this is here to connect you to this network. So this edge router here acts as only host router for these devices, and when you talk about three layer, it will be connecting you to the IPv6 interface, that is your web infrastructure, your internet here. So your IPv6 over low powered personal area network is an important IoT enabling technology. So that is how we can say that IPv6 is changing here the picture of Internet of Things. At each end, we can say that small object can be connected to the internet. We see here that the natural IPv6 format is not suitable for your Internet of Things. So we developed a lighter version, your IPv6 over low powered personal area network, which provides there an adaptation between the link layer and the network layer here. So this is all here for today's session. We will study more about Internet of Things in our next sessions. Thank you so much.